take out the warm-up. We're going to ignore the warm-up for right now. Today, we are doing translations. It says day 1. I don't even know what's going on. I meant to change the top part because I was going to take out the warm-up, and this should be... It really is day 1 of 1.2, but the way I'm looking at it is just it's more translations and reflections and stuff. Okay, really quick, the first part of the notes, there's nothing to do, but see, we've already talked about horizontal translations. Those go left or right. Those are inside. Those are opposite common sense. Vertical translations, up or down. Those are outside of the function. Those fit common sense. We've talked about this stuff already a lot. We've talked about reflections in the x-axis a lot. We just started talking about reflections in the y-axis, but I don't think we really practiced those till today. But,
can I move it a little bit?
Yes. Okay, so reflections in the y-axis. Yesterday, I'm pretty sure we went over this, but sometimes I forget what happened in one day. Reflections of the y-axis have a negative sign on the inside of the function. This is a horizontal reflection. It's a horizontal reflection, so it's on the inside of the function. So for example, y equals negative x squared would take the x squared function and flip it horizontally. So I'm going to be your model for a moment. This is an x squared. Do you see my U shape with my arms? If I reflect this horizontally, left or right, this is what you're going to get. Yeah, kind of. Okay, really it looks exactly the same because of this particular graph. If I flip it around, it looks exactly the same. But that's what a horizontal reflection is going to reflect it left, right. When we get into more graphs that are not symmetric, then it'll look a lot different. But we haven't really gotten there yet. Yesterday, we stood up and we danced, didn't we? So we talked about vertical stretches that would be like when I take your hands and I pull them vertically, it pulls the graph together. Or if I take your hands and I push them down vertically, that's a shrink and the graph gets wider. We talked about, did we talk about the actual values? I can't remember now, so I'm going to go over it again. So when we do anything vertical, it's common sense. So if I have something like y equals 5 absolute value of x, this is going to be a vertical either stretch or shrink. So I'm going to ask you, common sense, if I multiply by 5, because that's what's happening, 5 absolute value of x is 5 times absolute value of x. If I multiply by 5, does that make something bigger or smaller?
Bigger.
Right. Bigger, that is a stretch. 5 times something is a bigger number. But if I have y equals 1/3 absolute value of x, 1/3 of something will make it smaller. So if I take 1/3 and I multiply it by numbers, that's going to be a shrink. This is all common sense. If I have y equals -2 absolute value of x, this is not one transformation. -2 is not one single transformation. The negative part is separate from the 2. You guys should be able to tell me right now, what does the negative do? That's a reflect in the x-axis. Very good. And then the 2, does that make a number bigger or smaller? So that's going to be a stretch. So when you have a negative sign, that does not affect a stretch or shrink. That's telling you flip it. Okay? horizontal stretch or shrink. Horizontal stretch or shrink. We've got similar concept as vertical stretch or shrink, except for what we learned about horizontal already. Besides horizontals on the inside, horizontal is also opposite. We've already learned that horizontal is like always opposite of what you would think. So I'm calling it opposite operation. Now this table explains stuff, but I like to explain it with actual examples. So I'm just going to make some up. If I have y equals absolute value 5x, the 5 is inside the absolute value, that's going to say this is horizontal because it's inside. Inside the absolute value, this is multiplying by 5. But we don't do the same thing that's inside. We do opposite. So instead of multiplying by 5, what's opposite of multiplying by 5? Okay. We would divide by 5. Now, when we get to divide by 5, that's easy, but you're going to end up having fractions and stuff, and it gets really complicated. So instead of using division, I'm going to always change it to multiplication. So dividing by 5 is the exact same thing as multiplying by its reciprocal. So instead of dividing by 5, I can multiply by what number? Not 0.5. 1/5. So instead of dividing by 5, I'm multiplying by 1/5. That's what I'm going to really focus on is the multiplication. So if I take 1/5 of something, will that make it bigger or smaller? So this is a shrink. Now you look at it originally, you saw a 5 there, and you kind of want to say it's a stretch, but it's not. So horizontal is always opposite. Let me give you a different example. Y equals absolute value 1/10 x. So if I have y equals absolute value 1/10 x, we have to take out that 1/10 and we have to use it. But right now it's 1/10 times x. Do you think I want to divide by 1/10? Because I don't. So instead of dividing by it, I'm going to multiply by its reciprocal. What's the reciprocal of 1/10? 10. So if I multiply something by 10 times that number, is that a bigger number? Yeah, that's a stretch. So down here it's explaining like what makes it a shrink or a stretch, but I think sometimes just memorizing stuff doesn't help as much as thinking about what the numbers do. So that's the way I like to explain it, is what does 10 times something do? It makes it bigger. But it's all there if you want to read it. So we're going to go to example 1. So f of x equals absolute value 1/3 x. First thing I'm going to do is determine my parent function. I think I said it. Absolute value of x. So I'm going to pick x values. You can see my x column is in a different place than it was before because I set this table up for you already. My x column, I'm going to pick -2, -1, 0, 1, 2. And then I will put that into absolute value and I get all positives back. My transformation inside is going to be a horizontal something. So you will write horizontal. We have to determine if this is a horizontal stretch or shrink. I'm going to leave a blank for a second. I will go back and fill it in. Horizontal something. Then we write by a factor of, and we're going to write what we multiply by. So horizontal something by a factor of something. So I look at that 1/3 and I have to do opposite of multiplying by 1/3. So we're going to reciprocate it and we're going to multiply by what? 3. So horizontal something by a factor of 3. If I am multiplying by 3, is that going to make it bigger or smaller? So this is a horizontal stretch by a factor of 3. The words by a factor of 3, by a factor of, that means multiply by. You need to know that phrase because the word factor comes up in this course so much. I just haven't quite gotten there yet, but it will come up so much. So I'm going to keep repeating it over and over again. We need to know that a factor of means multiply by. All right, so in our table, because this is a horizontal stretch, I'm going to do it to the x values. And I do what it says in my words, multiply by 3 to my x values. Okay, I forgot to put my parent function down, so I'm going to do that really fast. I forgot to graph the parent function. So then when we graph the new function, we are graphing our outer x's and our outer y's. So I will be graphing the ordered pair -6, 2. -3, 1. 0, 0. 3, 1. 6, 2. So this was a horizontal stretch. So if we had our V's, we were doing our hands-on V's, and I pulled your arms horizontally, that would make it wider. If I pulled those arms horizontally, it would make it wider. Questions? More practice. Yeah, more practice. Let's look at the next one. So our next one is parent function x squared. So y equals x squared. So I'll pick my x values. I don't think this graph goes up to 9. This is a smaller graph than I normally use. So I'll just use -2. 1, 0, 1, 2. You know what? I lied. I'm going to use the 9. Sorry. I was indecisive. I just got to get more spaces in it. Okay, so I'm graphing my parent function really quickly here. The more you graph these guys, the more you're just going to like know what to do, and it becomes a lot faster. It does not seem like that much work. The more you practice it, it gets a lot faster. So I have my parent function in the table. I have my parent function graphed. Now we're going to list the transformations. You guys can see how both I told you there's 2. I didn't mean to, but there's 2 transformations. Both of them are inside of the squared. Both of them have a parenthesis around with the squared. Okay? But there's 2 transformations. Why am I saying there's 2? The negative sign is one of them, and then the 4 is the other. So we're going to list 2 things. What's a negative sign do? Okay, hold on. Reflect in the. Now, this one is a horizontal reflection. A horizontal reflection would be like if I have something over here and I reflect it left or right. Which axis does that reflect in? The y-axis. And then the 4 is a horizontal something. Horizontal stretch or shrink. I'll write it in a moment. By a factor of something. So if there's a 4 here, it's on the inside. When I go to multiply by it, I'm not multiplying by 4. What am I multiplying by? 1/4. So that's my factor of 1/4. Will that stretch or shrink? It's going to be a shrink. So we have a horizontal shrink by a factor of 1/4. So in my table, I'm going to take all of my x values and multiply them by 1/4. So I get -3/4, -2/4, which is -1/2, -1/4, 0, 1/4, 2/4, which is 1/2, 3/4. Do you guys notice our numbers are just awfully teeny tiny? Or it's just me? Do you notice that? Or is it just me? And really, I don't think there's much I could do about it. I could pick other points. Like I could use 4 as my x, which would give me 16 as my y. And that way, when I multiply by 1/4 to the 4, oh my gosh, I didn't multiply by the right thing. We'll go back. It's fine. I would get a 1. I didn't multiply by the right thing, though. I mean, I did, but I didn't. There was another transformation I forgot about. Huh? Not the exponent. That's not a transformation. That's the function. I multiplied only by the 1/4. What other transformation is still happening here? The reflection. So I can make that a separate step if I want. I can multiply by -1 now. Or I could just do all of them together by multiplying by -1/4, which is what I meant to do, but I forgot. So if I multiply everything by -1 at this point, it's just going to change all the signs. Except for 0 doesn't have a sign. So if you have a negative and you have a stretch or shrink, you can do it in one step. Does not have to be separate steps. Here, I can zoom back in. Did I lose someone on this? I feel like somebody's saying what, but not asking me. Sounded like a female, but.
Oh, no, I was telling you.
Okay. Daniel, do you have a question? Or anybody, do you have a question?
Wait, here, over it.
Yes.
I'm confused on why you have to times it by -1. Is that right?
Okay.
Can you tell them?
Yes. So this right here is 2 transformations. Negative is not a number. Negative means -1. And then the 4 becomes 1/4. So we have to multiply by both the -1 and the 1/4. I forgot when I first did it to multiply by just -1/4 because you can combine them and multiply by -1/4. So after I forgot to do that, I went back and just multiplied by -1. But if there's a negative there and a number, we got to multiply by both things. Okay. So the ordered pairs I'm graphing are, I'll write them over here. 3/4, 9. That doesn't fit on my graph because my graph's not big enough. 1/2, 4. 1/4, 1. 0, 0. -1/4, 1. -1/2, 4. And -3/4, 9. That's not going to fit on my graph. So just do your best. 3/4. Oh, that doesn't fit on my graph. 1/2, 4. 1/4, 1. It's a super, super skinny parabola. Hey, you can always zoom in way far to make it easier for you to draw. But it is a really skinny parabola. It almost looks like a V, but it's not a V. Because it's just super, super skinny. More questions? Give them to me. Yes. It's reflecting in the y-axis. So you know what this graph did? This graph was a U. Well, it is a U, but my pen stopped working for a second. Hold on a second. Here we go. All right, so the graph was a U, and then it flipped around the y-axis, and then it looked exactly the same. And if it's outside of the parentheses, it would go down. But this one's not. So it went side to side, and you can't even tell it flipped because it looks exactly the same. But eventually, we're going to have graphs that look like this. And then if I flip that, it'll definitely look different. It's just this one didn't look different because it's the same on both sides. Okay. Example 3, we're now going to describe transformations from the parent function to the function g. We're going to describe transformations. So we're going to look and see what's happening and describe it. You did some of this yesterday. I just have more transformations now. So I'm going to go left to right, and you know what? I'll color code them. So in purple, we're going to talk about the 7. If we are multiplying, it's going to be a stretch or shrink. 7 is multiplying. It's going to be a stretch or shrink. Oh, yes, but is it vertical or horizontal? Was going to be my first question. It's on the outside, so it's vertical. So it is vertical. And you guys already told me stretch by a factor of 7. So that's in purple. In pink, I have a negative sign. In pink, I have a negative sign. So that's going to be a reflect in the, so this is on the inside. It's going to be the y-axis because that's reflecting left or right, which goes over the y-axis. If I have a y-axis, I would reflect my little cute little cloud thing, whatever this is, left or right. Oh, they're pom-poms.
It's an angel. That's a tree from it's a cheerleader.
Or dancer. We use pom-poms too. Oh, her hair is ugly though. There we go. Now it's curly.
She's got a spike in her head.
It's a bow. There we go. All right. The 3/8. We'll do 3/8 in blue. Thanks. Oh my gosh, I have just so many choices.
You already have blue up there.
No, I don't.
It looks like you're colorblind.
I know he might be. There's a lot of boys that are. I've had boys that are colorblind every single year I've taught. So it's not your business if he is or not.
Yeah.
Okay. 3/8. That is on the inside. So we're going to start by saying that's horizontal something. So the way I do it is I figure out what I'm multiplying by first. So when I say by a factor of, I'm figuring out what I'm multiplying by first. So I'm going to reciprocate. I'm going to flip 3/8 and write 8/3. And is 8/3 going to make it bigger?
Yeah.
That's a bigger than 1. That's bigger than 1. That is a stretch. So then I'll go back and say, oh, that's a stretch. I said, oh, that's a stretch. And then we can do green. I feel like I need a different green, though. Let me replace my white. Oh, my gosh. These are like so Yeah, for real. Okay. So we'll do green for subtract 4. So that we should already know that's a translate where.
Oh, down.
So that's a translate down 4 units. Okay. More practice, more practice, more practice. B. I'm going to do the negative in the green because I'm already ready for green. Reflect or reflection. Either is fine. Reflect in the x-axis is in green. Here's your red, 2/3. That is on the outside of the squared. Shaq, are you okay?
Yeah.
Do you need help?
Not good.
Does Leah need help? Is he annoying you?
I don't think so.
Okay. 2/3 is on the outside of the squared. So it's not being squared. So that's vertical. So I'm going to write vertical. And then I need to know if it's a stretch or a shrink. If you're not sure, then let me finish the sentence. Vertical something by a factor of 2/3. We use the same thing. 2/3 is going to make it smaller, so shrink. Blue is next. I have a +6 on the inside of the squared. That is a translation or translate. 6 units. Amarian, why is it left? I know. Why is it left? If the answer is I don't know, we need to go over it. So why is it left? Well, yes, but why is it left? Don't tell him. Because it's inside, and everything inside, we do what? I didn't hear what he said. Hey, Shaq, do you need to have this seat today?
No.
I'm trying to hear him, and I can't because you two are talking. What'd you say, Marion? Why is it to the left? It's inside, and what does inside always do? The opposite. Correct. Okay, so we go 6 units to the left, and then we have this +5 on the end. So, and I'm not going to rewrite the word translate. You can if you want. And 5 units up. Amarian, why does it go up? Yes, because I'm adding. Why doesn't it go to the right? Because it's not inside. Good, good. All right, C. So the negative sign is first. Maddie, don't answer. You're fine. You're fine. Gabby, what does this negative sign do? Very good, Gabby. Megan, I have 9/2. Is that going to be vertical or horizontal? I'm going to leave a space. It's a horizontal something by a factor of Dominic. What factor?
2/9.
Yes, 2/9. Use the reciprocal. So if we multiply something by 2/9, mommy, that's a shrink. Very good. Is there anything else here? No? Okay. Oopsies. D. Let's start with this 2. add what together?
2 plus 6.
That's a very good question. Can we?
Yes. Yes.
Yes.
I don't see why we can't. Yep, because I want to. Boom. Operations.
What is the order of operations? Well, I know it's PEMDAS, but what is the order of operations? Okay. So we don't, well, the parentheses are the bars here. Those are parentheses, but inside I have -1 times x. There's nothing I can really do inside the parentheses. So we've done that. There's no exponents. Is there any multiplication?
No. Oh, yeah, 6 is absolutely not.
So I need to multiply 6 times the absolute value of -x first. But I can't do that because I don't know what x is. So after I do multiplication, I can do addition, but I can't do addition because I don't know this answer. So no, you cannot add those together. Okay. Guess why I put it that way? So we can talk about it. It's not to confuse you. Okay. So let's talk about what is 2 as a transformation.
It's gonna translate.
Is it on the inside or outside? Okay. All right. So we know it's something vertical. What operation is the 2 with everything else? What operation? What operation?
Oh, translate.
You're ahead of me. Operation is add, subtract, multiply, divide. So what operation is it? This is addition. If we do addition, we're talking translations. This is just written in an order that not all of them are written in. And I believe there was one like that yesterday. So that's why I brought it up again. If you wanted to see this in the order that everything else is, it would be written in this order. So it's okay that 2 comes first. It does the exact same thing. It's going to translate it. Where? Up 2 units. Yes. So that's the blue. Then we've got a 6 in pink. So what's the 6 do? It does. So that's going to be a vertical or horizontal. So vertical stretch by a factor of 6. And then we have a negative sign. And that is the y-axis. Yes, we're going to say reflect in the y-axis. You guys really, you're learning how to do transformations at the same time you're learning the vocabulary. And that's our last example. So your assignment today is a lot like yesterday's assignment. You just have some more stuff added onto it now. Today's assignment will be due tomorrow night.
Posting the video.
What?
When are you posting the video?
Well, I'm still recording it. So stop recording.